I don't know. It's up to
Till
9.
was there.
Till 9th it was given. Okay.
Yes, ma'am.
Till 10th.
Till 10th.
Yeah, ma'am, 10th was there.
Okay, 10th was also there. Let me then discuss this. See, first question says, yeah,
Ma'am, I had a doubt in the test.
in the weekly test, which one?
The dimensional formula, ma'am.
Dimensional formula?
Yeah. From the test series.
Not the weekly test, no, Maha?
No.
Is it checked?
No, I submitted. No, it was yesterday.
It was done yesterday.
Yeah.
Okay, so let me just check it first. Then I'll discuss because that this will give you also an idea, no? That how
Okay.
much you've done correctly, no? Okay. All right. Then just keep it in your mind, Maha. Otherwise, on Thursday, when you'll have the NEET class, that time we'll discuss. Okay.
Okay.
See, yes, I think I shared it out here. A body of mass 15 kg is hung by a spring balance in a lift. See, when you have a spring balance, that time also the upward force that will be acting, we consider that as the tension that acts. Okay, so you can take any force, you can write tension also, that will also be correct. And downwards is empty. So you have to first draw you should know how to draw the free body diagram. Most of the students have not drawn the free body diagram. Some of you have drawn it at the corner of your notebook, like it's a rough figure or something. No. Class free body diagram contains score. Okay, marks are allotted for it. So if your figures are not drawn, you might lose on marks. It says the lift is ascending with an acceleration of 2 meter per second square. Lift ascending upwards. It means ascending means upwards. Acceleration is 2 meter per second square. Now see here again we'll form the equation. What will be the equation that will be formed? Net force is equal to mass into acceleration. So tension will be positive because acceleration is upwards. So we'll write T minus mg is equal to ma. This will be it. Now, see, a body of mass 15 kg, what would be the reading of the spring balance? You have to tell the tension. You have to tell the tension. Okay, Shait says, no, what would be the reading of the spring balance when these things are affected?
Okay, ma'am.
Yeah,
That's
basically.
where I got confused.
Yeah, okay,
Thank
now
you,
I
ma'am.
think you'll be able to do rest of it.
Yeah.
Second one में वो नीचे जा रहा है and third one is constant velocity, so no acceleration. Okay. Coming to the fourth one, yes, I think Hafsa has it out here. See, fourth one also, you just have to resolve it. This is, I think, a question from your NCRT, this one also. Resolution of vectors will be needed here. See, this is your block and you have to calculate these tensions and only one of the angles is given. So see, this is where you have to resolve the vectors. See, if this is 60 degree, this will be 60 degree. Why? Because they are alternate angles. Now, if this is the case, then we'll have this one as T1 cos 60 degree and this one will become T1 sine 60 degree. Now see, are all the forces along x and y resolved? You have everything along x and y. Okay, T1 sine 60 above. This is empty. 4 kg weight. Okay, one thing I think I haven't discussed this with you all. Whenever kg weight is written, that means it's not just the mass given. It means it's given mass into acceleration due to gravity. So 4 kg weight means 40 Newton. Okay. Whenever you have to convert kg weight, 1 kg weight is equal to 10 Newton. Like this, you can convert. Okay. Basically, it's that you are multiplying it with acceleration due to gravity. In fact, it's better you just take the value instead of 10, you take it as 9.8 meter per second square. So this is basically saying mg is acting downwards. Weight means acceleration due to gravity is acting downwards. Okay, now see, both forces are balancing. This means 40 Newton is acting downwards. This is basically the mg that acts. Okay, T1 sine 60 above, T2 here, T1 sine 60 below. Now, see here, if we take up the ratios, we can say clearly here that T1 sine 60 degree is equal to 40. Okay, T1 sine 60 is balancing 40. So sine 60's value we already know. So this will be T1 root 3 by 2 is equal to 40. So from here T1 is equal to 80 by root 3 Newton. Now you balance T1 cos 60 degree with T2. Now you already know T1. So it's like T1 cos 60 degree is equal to T2. So directly T1 you have already calculated as 80 root 3 into half is equal to T2. So T2 will be equal to 40 by root 3 Newton. Got it?
Yeah, ma'am.
Hafsa?
Yes, ma'am.
All right. Fifth, sixth class, we have already done it in the class. Fifth one also you should try by yourself. Okay. From the leftover questions from this assignment, I'll give it to you today because these assignment questions are very good. Well, here these are from the reference book. But this one is from your NCRT. This one is from the NCRT. This is from your NCRT. This elevator is from the NCRT. This rupee coins one is from the back exercise. This is also from the back exercise. So all these questions, this one is from your NCRT. So it's a very good question. Once you practice this assignments, important questions of this topic will be covered directly from the NCRT itself. Okay. So yeah, rest of the questions, one or two questions are there that I'll give or we'll discuss later. See, this says a man weighs 70 kg, he stands on a weighing machine in a lift. See, lift comes, no, just keep your mind towards those four cases that we did. Okay, that only will be used. Those four cases. Remember, apparent weight which we did. So that way only it will be done. So same thing it is. See, 70 kg, a person is there in a lift with a weight of 70 kg. Okay, if a man is there and you don't figure if the man is standing on the weighing machine, you don't have to care about that. For you, 70 kg is the mass given, inside mass is given as 70 kg. Okay, now it says upwards with a uniform speed. As soon as you see upwards with a uniform speed means no acceleration. In the first case, acceleration is 0. In the second case, downwards with acceleration, same thing, guys. I think here by now you should be able to write all these equations. 70 kg is the weight. So downwards, 700 will be acting. Okay. Upwards, tension will be acting. Now see, in this question, Aisha, you must be again confused what you have to calculate. Tension only. Okay.
Okay, ma'am.
Weighing machine stands. What are the readings? See, weighing machine, spring, weight. These were the things you were getting confused with. Look, what are exactly these things? They are telling the weight. What did I tell you earlier? Mass is basically what we have, what we weigh on the weighing scale. Okay, that is our mass that we say. Now, mass multiply when you have, let's say, the mass is given as 70 kg. The man's weight was 70 kg. Now, if I say force, that becomes m into g. Whenever you have the weighing machine, you have the spring balance, these give the net forces. Okay, they give the resultant net forces. That's why you're able to calculate. Otherwise, you'll always have these acceleration due to gravity is always acting downwards. Okay, so it's the same question. Here, the acceleration will be 0 upwards with this acceleration downwards. So T minus mg is ma, T plus mg minus T is equal to m in those same equations. Okay,
Yeah, ma'am. Thank you.
all right.
Ma'am, can you show the question 4? I want to write just little bit.
Okay. Yeah. Write this first, then let me know. Okay. Okay. Rest of you have also written. Those who had it out. Hafsa, done?
Yes.
Yes, ma'am.
Okay. All right. So let's go to the next one. Create. Okay, ninth one. The ninth one is also very easy. It's just that it will require a little figure. You have pile of coins. No, if you put one coin on the top of the other. So it's something like this. So it says 10 coins are put. 1 rupee coins. These are 10. They are put on top of themselves. Okay. So 1, then 2, then 3, 4th, 5th, 6th, 7th, 8th, 9th, and 10th. Okay, this is how the coins are put. Now it says the force on each one will have the mass m. Okay, it is given in the question. Each of them has the mass m. Now the force on the seventh coin. Seventh coin means the third one. Why? Because it says counted from the bottom. If you count the seventh one from here, so this will be the 10th, 9th, 8th, 7th. Okay. So which is our seventh? Seventh coin is this. This is the basically the seventh coin. Okay. This is the coin. It says the force on this due to all the coins on its top. So how many coins are on its top? 3 coins are there. So total mass that will be held will be all the masses due to each of them. So it will be m plus m plus m. 3 mg will be acting. If I draw closely the force on the 7th and 8th, this is how it would look like. This is the 8th, this is the 7th. So see here, 8 will be exerting 3 mg downwards like this. So what's the fourth on the 7th? It's said straight away 3 mg. Okay. Now what is the fourth? It says what's the force on the 7th coin by the 8th one. Okay. Just by the 8th one. This is the 8th one.
2 mg.
No. See. In the first one, the force on the 7th coin due to all the coins on its top. So it was 3 mg because that was acting.
Ma'am,
Now
will it
see,
be mg?
yes,
Will it be mg?
no, not mg. See, Hafsa was close. 2 mg part, Hafsa, that was fine. Okay, but what exactly is 2 mg? If I draw the ninth and 8th, if I draw, this is the ninth one, this is the 8th one. Okay, ninth and 8th. Now, what's the force ninth is exerting on 8th? You tell me.
Ma'am, what's the question?
If I say the question, this question was the force on the 8th coin due to all the coins on its top. What would have been your answer then?
And 2 mg.
2 mg, right? So that
Yes.
means the ninth one is exerting a force of 2 mg on 8. Okay. Now, what's the
Yes, ma'am.
question? Let's come back to our question. If 8 is still 8, it is 2 mg. It says force on the 7th by the 8th coin. Aren't these two questions the same? 8 will exert whatever it is receiving. Do you think this 2 mg is acting on the ninth to 8th? So that same exact 2 mg will be passed on till the 7th. No weight of 8. 8 coin will be there. It's
Yes,
actually
ma'am.
the same question. Okay, this is the same question. It's just it has been written in the manner that okay, 3 due to all the coins on its top. Force on the 7th by the 8th, 8 is on its top, and the 8th coin is exerting all the force due to all the coins on the top. So it's the same thing. Okay. 3 mg, 8th is receiving 3 mg, it's giving 3 mg. Now this will be different. The reaction of the 6th coin on the 7th. 6th means this one. This is the 6th one. Okay, this is the 6th one. So if I draw 6th and 7th separately, see this is the 7th, this is the 6th, this is the 7th. Okay, this is 6th. Oh no. This will be 6th, this will be 7th. Okay. Now see it says reaction. Reaction means action to a reaction. Action is exerted, then a reaction force is being given. So what's the action? First, for any reaction, we have to first identify the action. So what's the action here? Action will be whatever 7th is exerting on 6th. Sixth will give the same reaction. In the sense, if I have all these questions, if 3 mg is being exerted by 8 and 7th, how much 7th is reacting back? 3 mg back on 8. That's what the Newton's third law is. If 2 mg is coming on 8, 1 due to 9th and 10th, how much 8 is giving back to 9th? 2 mg exact reaction force. So if I know my action, I'll be able to write the reaction because just the direction would be the same. The magnitude would be the exactly same value. Direction would be opposite. Magnitude would be the same. So how much 7th will be exerting on 6th class?
4.
4. Very good, Hafsa. 4 mg. 1, 2, 3, 4. Right? All the 4 will be exerting on it. So 4 mg is now acting on this one. This is the sixth one. See, 1, 2, 3, and 4. So 4 mg is acting on the sixth. The question was the force on the sixth coin. Due to all the coins on its top, it would have been 4 mg. Now, what's the reaction of 6? 6 will exert exactly 4 mg back on 7. That's action reaction. So this is 3 mg, this is 3 mg, and this is 4 mg. Tell me now, is this question clear to all?
Yes, mom.
Okay. Quickly write down this one as well.
Ma'am, can you explain it once again? I have bad network, so I keep on getting disconnected.
Okay. Which question, Maha? This one.
Yeah.
See, Maha, there are 10 coins present like this. So the question says, the actual question was, the force on the seventh coin due to all of these. Okay. So seventh is actually the third coin from the top, means fourth coin from the top. Coins are already there. 10th, 9th, and 8th are already there like this.
Yeah.
10th, 9th, 8th. So when the force is being exerted on the 7 by all of the coins on the top, it's due to all the 3 coins. So all the 3 coins which are having each of the mass as m will give a total weight of 3 mg to 7 mg
Oh,
plus
okay.
mg. Okay.
Because 3 coins are on top of it.
Coins are there, exactly. And it says what's the fourth force on the seventh coin by the eighth coin. So eighth coin is not just a separate coin. Eight will exert whatever forces are on the top of eighth. Eighth will only pass on that. It means these two are the same questions due to all the coins on its top or due to the eighth one. Ultimately, eighth one is only delivering the 3 mg force on seventh one.
Okay.
So this is 3 mg. It is reaction of the sixth coin on the seventh. Now, for finding out the reaction, you should know what's the action. So here the action is basically what's the force getting exerted on the sixth due to seventh. 4 mg because now 4 coins are on the top of 6. So the reaction will be exactly the same.
Okay.
Okay, so 4 mg. Just write it. One more question we'll discuss then.
Ma'am?
Yes.
Ma'am, yesterday we had a physics revision test. In the last question, I had a doubt.
Yes. Maha has told me. Let me just check your revision test sheets first, Sanidhi. Okay.
Okay, ma'am.
Then I'll discuss it. I actually haven't received your answer sheets back. Who all
And
have given?
also, ma'am,
Yeah.
in the question paper, usually in the question that we practice, like a question will be given and you will, like it will be given like what is P, what is V, and all of that, right? But then over in the question it wasn't given in some of them. So it was like very confusing. Is it like volume or is it velocity and all that?
It wasn't mentioned in it.
Like some
Actually,
of
I
them it
haven't
wasn't
done this.
mentioned.
These revision sheets aren't made by me, so that's why I don't know. Let me just have the question paper. Let me take it right now. Okay. The
Okay.
weekly test papers that I share with you, that you have, those tests I have made. But these revision one I haven't made. Okay, so that's why I'm not aware of the questions and all. Let me just take the sheets one so that I can discuss with all of you then. Okay.
Okay.
Let me just talk about this revision. Okay, class. So this revision testing, I'll just tell them, and I'll also ask them to just show me the paper once, so that these random things are not happening. Just tell me one thing: only dimension analysis was done, or was there any other chapter combined?
Only dimension analysis full set.
Okay. Sanidhi, Aisha, and Maha have given. Anyone else? Hafsa and Ikra?
Ma'am, I have test today.
You have it today.
I have submitted.
Nabila has also given. Okay. All right. See, this last question, I think, for today. Yeah. Block of mass 25 kg is raised by a 50 kg man in two different ways. One, he is pulling it directly. Second is he is using a pulley for the same thing. Okay. It says what's the action on the floor by the man in two cases. When it says action, you basically have to calculate normal reaction. See, normal action, reactions, see, they'll always be combined and they'll always be equal. It says if the flow yields to a normal force of 700 Newton, which mode should the man adopt to lift the block without the floor yielding? Floor yielding means the floor shouldn't break off, okay? Because of so much weight, so much energy is acting on the man, so the floor shouldn't break off. So first part is very easy. You just have 25. See, in the first part, the mass of the man is given as 50 kg and the block is 25 kg. Okay. In the first case, you say let whatever is the force exerted by the man on the floor is some N1. Just take it as some or R1. Take it as some R1 or N1. Some reaction is there. Okay. Tension is acting upwards. So this tension force will be there downwards. What will be? The mg will be acting. Okay, downwards mg will be acting. Now see here, this is I'll just write it as 25g because two kinds of masses will be used, no, mass of the man and mass of the floor. This is tension, this is 25g. And let's talk about the man, because it says no yields, the floor yields. So basically we are concerned about this floor, so we should know what's the total mass occurring here. So one of the forces that we had was this. Other force will be, this is, let's say, the normal reaction of the due to the man and the mass. So let's say I'm writing this as 50g. Okay, and one here, 50g here. This is the tension. This is 25g. Now look, whatever is this tension occurring over here, as we did in other questions which we practiced, class, didn't we write this as the same tension that is occurring? If I just draw the free body diagram of the man, these are the three forces that are acting. Tension will also be acting because the person is in contact with the thread, with this rope. So do you get it till here, the free body diagram in the first case?
Yeah, ma'am.
Okay. Now see, normal reaction is there and your tension is also there and your weight is also there. Okay. Mg is also there, tension is also there, normal reaction is also there. So normal reaction, when we are talking about, this will be here in this case particularly. See, this is moving upwards. If this is going upwards, so let us take the normal reaction here. Basically, the normal reaction and tension and 50 g, they are being balanced. Forget about this part. Just look at the person. Okay, I have not drawn it separately, though when we draw the free body diagram, this should be drawn separately. Now tell me, class, is the man moving along y-axis or along x-axis?
No.
No. So if the man is not moving, it means N1 is balancing T plus this 50g. That is one equation that you will get from here. And normal reaction will be tension plus 50g from this side. Okay.
Ma'am,
Now
can you explain this again?
see, just look at the man. If I talk about the man, let's say I am drawing all the forces that are acting. So above is the normal reaction N1 acting. Aisha, downwards is the person's weight acting, 50g. 50g means not 50 grams. 50 into 9.8 meter per second square. Okay.
Yeah.
Mg. Okay. And see, there is one, this tension also acting due to this rope. Due to this rope, tension will also be acting.
Yeah.
But tension on the man, I'm not focusing on the tension on the block. We've already discussed this in the class as well. Okay. So this will be the tension that is occurring. Now see, the person isn't moving anywhere. The man isn't going up, down, or forward, backwards. Means man is not
Okay,
accelerating.
got it.
Okay. So
Yeah.
this is balancing these two. Clear?
Yeah, mom, got it. Thank you.
Okay. Now it says, what is the action of the floor if the floor yields normal reaction? Which mode should the man adopt to lift the block without the floor yielding? It means the block is raised without any acceleration, right? Means if this wasn't being lifted by the person, we'll straight away say that tension is equal to the 25G. Here, do you now look at the second part? Tension is equal to the 25G. Yes or no? Yes.
Yeah.
Okay. Now see, if you put the value of tension 25, 50, 75G, so 750 Newton, around 750 Newton, you will get the normal reactions value. N1 will be 750 Newton. So this is what you're getting from the first case. Just put it aside because you have to compare it with the second case. Now look at the second case. In second case, the
So what
direction
about the acceleration?
acceleration you will not have any
So in
acceleration. Okay.
block.
For the block only, I'm saying. See, block right now you're not considering any movement. Okay, you have to see movement term will come. The acceleration of the block or of the man will come as a whole, as a system. Okay, together, complete system will be there. So when you're breaking it into parts, the block is to be raised without any acceleration. Okay, the block, if the block you are not raising it with certain value of acceleration, see in this case then you will make the equations T minus mg is equal to ma and all. Okay, so acceleration, it means you have to raise the block without any acceleration. That's why we are saying the acceleration here is zero, acceleration here is zero. Currently in this situation, okay, in this position, block hasn't been lifted by the person. This movement part you don't have to consider because the question says you just have to see which mode he should apply to lift the block. Because if it is yielding a normal reaction of 700 Newton, when the movement occurs, then the floor will be yielded. If the movement occurs, floor will be yielded. We don't know which case is better. So we are assuming, is this, imagine as if everything is stationary. Now we are just checking the positions. If this first one is fine or second one is fine. Got it? So in both of the cases, don't consider acceleration right now. Acceleration will be given if there was a third part. That yes, you have calculated which method is correct. Now calculate with which acceleration should the block be lifted. Okay? Is that clear?
Yes, mom.
Okay. See, for the second one, see here, same thing. In the second case, you have to have the forces exerted, but you will say there's some force exerted N2. Okay. And similarly, this mg will be acting, but the direction of tension will be different. Okay. What will be the direction? Tension will be here. The normal reaction will be here. Let's say the N2 is here, and this is again 50G. So I think this time your N2's value will be a little different. What will be N2? N2 will be, see, N2 plus T will be equal to 50G. So N2 will be equal to 50G minus tension. Yes, this would be in this case. Yes, and see,
Yeah.
tension from this side, the tension is still balancing the 25G. 25G, when I say, please don't get it confused with grams. This is not grams. This is acceleration due to gravity. So N2 will be 50G minus 25G. N2 will give you 250 Newton. Now it clearly shows which method should be adopted. Second method should be adopted because this is giving you a higher value. Floor can only tolerate 700 Newton. Okay, so what it is saying that you cannot exceed 700 Newton. And the first one is already giving a normal reaction of 750 Newton. All right, so in this case, if the second method is being used, you're getting a force of 250 Newton. So that should be adopted. Now see, Hafsa and all who were asking about the acceleration. If the second part was calculate the acceleration with which the block has to be lifted, then you put this acceleration and then you calculate T minus 25G is equal to MA and all. Okay, but that's not asked, so this much is sufficient. You just have to use this and this. Got it?
Yes, ma'am.
Okay. Quickly write down this question as well, those who had the doubts. Aisha, are your doubts now clear?
Yes, mom. Thank you.
Okay, please write. Maha and all those who were telling me about the test, what was the exact problem with the revision test? Could you just tell me the problems that you faced?
Ma'am, in the 16th one, like, what exactly were the values one question? Like, what is P? What is another? What is V? Because V can either be velocity or like volume, right?
Okay, in the 16th question, that wasn't the one, I think, Maha. Van der Waals equation one, no? A and B, find the dimensions of the constant
Yeah.
A and so this we've already done it in the class. V was the volume. We've done it in the class. This is
But
a
then
question.
you mentioned like what was V and all.
Okay. This wasn't mentioned that what was P and what was V and all. Okay. All right. I get it.
And ma'am, I couldn't solve the last one.
Ma'am, me too. I could not solve the last one.
Okay. The CGS conversion, Stephen's constant.
Yes, ma'am.
Okay. All right. I'll discuss all these then. Yes, done class.
Yes, ma'am.
All right. Then for pseudo force only, Sanidhi has submitted yesterday. Sanidhi, I've checked your sheets yesterday and shared it with you. Okay. So this one I'll start with next week, the pseudo force assignment, because rest of you also give it. And right now, a lot of time has already been gone. Now, yesterday, I think this was left to write. You couldn't
Yeah.
write this one. No? Okay. Just copy down this question and then we'll start with angle of friction and angle of force. Okay. Please write this first, class. And everyone?
Yeah, ma'am.
Yes, ma'am.
Yeah.
All right. So see class, coming to angle of friction. Angle of friction is very easy. Pay a little attention. See what all things are there. This is a block and I've drawn the free body diagram of it. There's a normal reaction that is acting upwards. Downwards is mg. And on the right hand side, I've drawn the applied force. So obviously if the applied force is on the right hand side, so the friction force will be on the left hand side. Okay, just focus on these four right now. Now see, if I talk about the applied force, normal reaction, this is the weight. Normal reaction is actually balancing the weight, and applied force is balancing the frictional force. That means it's a static friction acting. Now, if I just talk about the normal reaction and the frictional force, like if I have the normal reaction, this is the normal reaction, okay, and this is the frictional force. So both of these are forces, both of these are vectors. Now two vectors making an angle of 90 degree, that's what we have to solve. So if two vectors are making an angle of 90 degree, first of all, the step that we follow is we complete the parallelogram. In vectors we have studied, we complete the parallelogram. Where is your resultant? This is where your resultant is. This is where your resultant will lie. Okay. Now see, what is this angle of friction? Formula wise, it was very easy. I'll just tell you. This angle that the normal reaction is not making with the frictional force. Normal reaction is making with the resultant of normal and friction. What is this R? See, there are two things here. One is the normal reaction. Okay. This is the normal reaction. And what is this? This is the resultant of normal reaction and friction. So angle between normal reaction and resultant of normal reaction and friction is the angle of friction. Okay, now come back to here. This is your theta over here. Okay, so it's written, it is the angle which the resultant of the normal reaction and friction, resultant of normal reaction and friction means this, and the normal reaction makes with the and the friction makes with the normal reaction. Okay, so this is your angle of friction, theta. Now this R, N and O here, I just marked a point here, which is P, which is here it is Q. So if I just write down tan theta from here, it's better if we take this triangle. If we take tan theta, what we get? This will be the perpendicular. This will be the base. What will it be? This is your triangle QPO. I'll write it in triangle QPO. What will be your tan theta?
QP by N? No,
QP
QP
by,
by ON.
this is P.
QP by ON.
OP, no? N.
Oh, yeah, sorry. QP
QP
by
by,
OP.
yes. This will be QP divided by OP. She's right. Now see class. What exactly are these? Like in terms of the variables, it's very easy to find, okay, QP by OP, OP by this and all. But when you're writing it in terms of the known forces, you have to relate it. Okay. So when I'm talking about QP, can you see this side is exactly parallel to this side? Whatever will be this force will be exactly this force. So we can say the value of QP here is the frictional force. And what about the OP? OP is already lying on the normal reaction. So this is clearly saying that OP is your normal reaction. So if we put in the values, we will get tan theta is equal to the frictional force, divided by the normal reaction. Now, what's the formula of the friction force, class? Yesterday we did it.
Mu N.
Mu n. Very good, Aisha. Frictional force is equal to mu n. So if I put mu n divided by n, normal reaction will be cancelled. Tan theta is equal to the coefficient of friction. So whatever you get, if it's a very different angle, you just write tan inverse and whatever is the value of this mu, and that's it. Calculation wise, it's very easy. You just had to understand it. That's it. So I'm just repeating it quickly. See, what is here? The normal reaction is acting upwards, mg is acting downwards. On the right, the applied force is there, and on the left, friction force is there. Then we just zoom in to the normal reaction and the frictional force that are acting at perpendicular to each other. Normal reaction and friction, their resultant is taken as R. The angle between this resultant R, which is the resultant of normal reaction and friction, whatever angle it is subtending with the normal reaction, this is considered as the angle of friction. And how to calculate it? If we take this triangle, this triangle that we have formed with the angle. So if we calculate the tan of it, that will give us the perpendicular by the base. Perpendicular is parallel to the friction, so we'll just write it as the friction force, while this is already the normal reaction. Friction forces formula, we know it is mu n. Normal reaction gets cancelled. Tan theta becomes equal to the coefficient of friction. Is the topic clear?
Yeah, ma'am.
Okay.
Yes, ma'am.
Right. Then one more angle part comes, angle of repose, that I'll discuss. First, write down this one.
Done, ma'am.
All right. So I hope everybody has done. If anyone is writing, please just stop me.
Done, ma'am.
Done? Okay. Now there is one angle of repose, or we say angle of sliding. It's also very easy. Formula wise, these questions are very easy to solve. Okay, you don't have very tough solving part here, at least in this. Okay, and before also, when you were calculating the tension forces and all mg and all that used to calculate, basically the writing of equations and applications of formula part is important here, as you'll be able to manage. Now, what is exactly the angle of repose? I'll just tell you. See, this is a surface, okay, and if I have anything on this surface, okay, I just put this pen on this surface. Now as soon as I'll incline it, what will happen? This should be a rough surface, by the way, okay, because we're talking about the friction. So this is there. Now see, this is the pen on it. Now as soon as I'll slide it, what will happen? The pen will be just moving like this. It will move down here. Now see what happened here. When I had it, and it was like this initially. Now, as soon as I inclined it a bit, this was the angle with which the pen was about to move, and then it moved. So this angle, if you see it very slowly, this angle that initially forms when the object is just about to slide or just begins the sliding, that is known as the angle of repose. Okay. So see, what's it? It is the minimum angle of inclination at which the body just slides down, okay? Minimum angle of inclination, the angle at which the body is just about to just slide. Okay, see here, if I incline it like this, though this is a rolling object, this will roll down on it. But if I take a rough surface, it's not necessary that it will always slide down. Okay, when we're talking about the inclination, it's not necessary that it will always slide down. If I just take some another surface like this, okay. Now see, I have inclined it a bit. It has not slided yet. Okay, fine. This one, as soon as the body slides, the minimum angle, that the first angle that you get of inclination, that is acting as your angle of repose. Okay, the body just begins to move, that one. Okay, so when we talk from here, you'll have the questions related to motion of an inclined plane. So pay attention here, because whatever resolution part we will be discussing over here, that will be carried on in your motion for inclined plane. Now let's say this is the object of mass m and this is theta, and various other forces are acting on it. And the forces are acting, see, downwards we have mg acting, and I think in one of the tests, not tests, in one of the assignments, there was something related to inclined plane. So I told you just pay attention in the inclined plane one, then you will be able to understand, because here you have to perform the resolution of vectors. See, downwards mg is acting. Now this time, how the normal reaction will occur? If I have something like this, so normal reaction acts like this. But if I shift it, so normal reaction will also be shifted. Correct, class? So here, if I take the normal reaction, this is how the normal reaction. But see, class, the rules are different for inclined plane. What did we study till now? We studied that whenever you have to resolve any vectors, it has to be along the x-axis or the y-axis. This is what we've already studied. Yes, x and y. If anything is beyond that, means it's in the xy plane, yz plane, or it's in the second quadrant or the third quadrant, we immediately resolve it. Like the one which we did, the assignment question which we did it today, the tension one that was acting in the xy plane. So we had to resolve it along x and y axis. This isn't the rule over here for inclined plane. For inclined plane, how do you have to resolve is perpendicular to the plane, or I'll just see parallel to the plane. Everything will be along the inclined plane. Okay, I'll just write it. Perpendicular to the plane. Plane means to the inclined plane. Perpendicular to the inclined plane. Second is parallel to the incline. You don't have to consider x and y axis. It means this is the line. Perpendicular to it means like this. So your vectors will be resolved in this manner. Basically, the forces that will be occurring, okay, they'll be resolved in this manner. First, tell me, till this much part, is it clear? I'm just quickly repeating, and if there's any doubt, let me know. The angle
I'm
with which,
parallel to
yes,
which? Parallel to
plane, parallel to this plane, this. That's why I've taken this. Okay. Like,
what's the
this is it.
parallel? Like which Newton? So this force is parallel or mg?
No. Whatever forces will be acting, not just normal reaction or mg. Other forces can also act. If I take the friction
Okay.
force, then no, I have just told you where you have to resolve. Whatever forces you will be resolving should be parallel to this plane like this, and sorry, parallel to the plane of the incline and perpendicular to it. Okay, this is the perpendicular way and this is the parallel way. This is how they have to be resolved. See, they are lying in the different planes. How do we resolve the vectors usually? We resolve the vectors along x-axis and y-axis separately. Right, that's what we've studied, x-axis, y-axis. So this isn't the case now. If you have the plane like this is your inclined plane. So perpendicular to the inclined plane is how you have to resolve, and parallel to the inclined plane you have to resolve the vectors, whatever vectors are there. It's any vector, resolution of
Mom,
vectors.
how to resolve it parallelly?
No, that I'll tell you. Resolution part I'll tell you. This much is clear. What's the rule first?
Yeah,
To all.
ma'am.
Others also?
Yes, ma'am.
Yes,
Okay.
ma'am. Yes.
Now see, how do we resolve it? See, this is 90 degree. Yes, this is 90 degree. So if this is 90 degree, how much this will be? 90 minus theta. Now total is again 90 degree. So this angle will be theta. Now class, for the first time, just remember it like this. And for the next time, don't show it 90 degree, then 90 minus theta, then theta like this. Straight away, if this is the angle of inclination theta, then this angle will also be theta. Okay, directly. Now you know why it will be theta, but you don't have to mention it all the time. Now see, this is theta. We are going to resolve mg first because see, this is neither lying along the perpendicular or the parallel. So mg is wrong here. Usually mg is correct because it is acting downwards along the y-axis. But here, according to the rules of inclination, this is incorrect. So we are going to resolve this mg. How are we going to resolve mg? It is making angle theta here. So can anyone tell me what will be the component here?
mg cos theta.
Mg cos theta, very good. This will be mg cos theta. And see, perpendicular to this means this. This one. This means mg sin theta. Look, isn't it parallel to the plane? Aisha, you were asking how to resolve it parallel. Got it?
Yeah, ma'am. Okay.
Okay. Now see, here when we are drawing the forces, now you have to see. Now let's talk about this part is here, mg and normal reaction part.
Yeah, ma'am.
Yes, ma'am.
Okay. All right. So see, now let's bring up the other forces as well. What can act? The friction force will also be acting if it's not a smooth plane. Though if the question says it's a smooth inclined plane, then till here it's fine. Whatever question says, answer. But tell me, class, where will the friction force occur according to all of you? Where should I draw it? Because friction
In
is
the
there.
opposite direction to mg sin theta.
Yes, very good. See, body has the tendency to slide down. Friction force will act in the opposite direction to resist it. Exactly here, the friction force will be acting. She's right. Okay. Now see, now we just have to balance on the things. We are not talking about the movement. We are just saying if the body is still. So the upward forces balances, downward forces, this force, that force. We are just balancing the equilibrium of forces. So we can say the friction force is balancing which force? Nabila, you tell me.
mg sin theta.
Mg sin theta, very good. Friction force is balancing mg sin theta. And normal reaction is being balanced by which force, Sanidhi?
mg cos theta.
Mg cos theta. See, normal reaction, mg cos theta is balancing. N is equal to mg cos theta. Answer will be the same. Let's take the ratio. See, you will see yourself, the answer will come out to be the same. Mg sin theta divided by mg cos theta is equal to F by N. MG gets cancelled. Yes, Maha. What is sine theta by cos theta?
Tan theta.
Tan theta. We are getting tan theta back. Hafsa, what is the formula of friction force?
Mu Newton. No, sorry, force
Not
and
Newton.
and
Normal
sorry,
reaction. Yes.
sorry.
Okay. Don't get it confused with Newton is the SI unit. Yes, normal reaction. Okay. Mu n divided by n. You're getting the same formula. Coefficient of friction. So in the exam, derivations can come. So they have to be written separately. I'll discuss the question also with you. Let me discuss this. Or do one thing, write it till here, then I'll discuss the questions. Okay. Things will be clear. So this derivation is very easy. You just have to understand the resolution part. Okay, please write it.
Can you scroll down? Done, ma'am.
Done, ma'am.
All have completed?
Yes, ma'am. Yeah.
All right, okay. Let's see a question. This is
Ma'am,
37
this is
degrees
the
the angle
same
of
question we wrote before, na? Angle for of friction.
which? This one?
That
Formula?
same. This
Yes,
one.
yes. The formula is exactly the same. Mu is equal to tan theta. Okay, that's what I was saying. The formula will come out to be the same. In fact, there is one more thing that will come after circular motion that we'll see. That is also exactly the same as this formula, very similar to this. So this is an inclined plane. Now see, we'll have mg acting downwards and normal reaction acting perpendicular to the plane. So see, directly have this angle as theta, and this becomes your mg cos theta. This becomes your mg sine theta. And since this has a tendency to slide downwards, the friction force will act like this. This part you should be able to do and you should be fluent with it, okay? It says normal reaction. So first part, normal reaction should be equal to mg cos theta. This is actually a straight line class. Just draw it a little better. The normal reaction will be mass of the block is 10, 10 into cos 37 degree is there. 37 degree is given as 4 by 5. See class, few data should be remembered by you. Cos 37 is 4 by 5. Cos 53 is 3 by 5. Sine 37 is 3 by 5. I think I've made you right when we did
Yeah,
resolution.
ma'am. Other than the angles
Yes.
done in
Yes.
it's 37 and 53.
Correct, yes. 37 and 53 because they're often given in the exams. Yes. So, all right, so that makes it, this is 2. So normal reaction becomes 80 Newton. Now see, this is Newton, this is normal reaction. Second part says friction is coefficient of friction is given as 0.3. So friction force C, second part will be friction force is equal to, see, your friction force is balancing mg sine theta also. You can calculate it by that method or straight away, because it means if it has given you the coefficient of limiting friction, so it means the body is about to move, you straight away use the formula. It is mu L into N. So straight away you write it as whatever it's given, 0.3. This becomes 0.3 into 80. Okay, no need to write down mg sine theta and all, because you have, when you have the direct formula, if normal reaction wasn't given or anything, then you could have written. Okay, so that's it. This will be the answer then. That this will be 24 Newton. Okay, write this question. Okay, see now kinematics of circular motion. As I told you earlier only that I'll be teaching kinematics of circular motion or what? Circular motion as one topic I'll be teaching you, okay? Once this is done, then whatever are the left portions of individual chapters that we'll see. Because once this is done, a major portion of your rotation will be done and then the syllabus will be done very quickly. Work, energy and power won't take time. Rotation, which would have taken time, won't be taken time if we do it all
Ma'am,
together.
is chapter finished? Like laws of motion
Yeah?
finished? This chapter completed?
There's a small topic which is related to the circular motion. Other than that, it's completed. But circular motion is there in your laws of motion also, a bit portion of it. So that you'll be able to understand when we complete the entire circular motion. Okay, so that's why I'm taking the circular motion first. But you can study laws of motion, you'll be able to solve the questions and everything. These just there are three topics that are there in laws of motion: bending of road, banking of road, and bending of cyclist. That we'll have to do. That's more of an application of the circular motions. Okay. Otherwise, rest of the chapter is done. So practice it also. If I could get one class with you extra this week, the problem is that your timings aren't matching. You have Tuesday, some students have the bio class, timings aren't matching. Otherwise, one class is needed. One extra class is needed to cover a lot of portion. Because by now we should be towards the end of circular motion. Or what I'll do in the next week,